So, hello everyone, and welcome to today's class. Before we start discussing today's topic, I would like to give you some work to do, and this work is related to what we covered last week. So you can note this down. So let's look at sampling methods, and we start by saying that sampling methods can be broadly classified into two. We have what we call probability sampling methods, and then we also have the non-probability sampling methods. But before I mention the other method, let me say that a probability sample is one where the selection of units or elements or individuals from the population is done according to some known probabilities. So you know the likelihood that a particular element will be chosen into a sample. Examples of probability sampling methods include I'm only going to give the ones that we shall be discussing in this class. We have what we call simple random sampling. We have what we call stratified random sampling. We have number 3, cluster sampling. I should have said cluster random sampling. And then we're also going to discuss systematic random sampling. So in this class, we shall restrict our discussion to those 4 probability sampling methods. Usually, you will always find that you can find a mixture of any of these 2. So you can find a combination of several sampling methods to get a new method. So we also have what we call the mixed sampling, which is a combination of different sampling techniques. But we shall not be discussing those ones for now. The number 2, or part B, the second classification or class of sampling methods, we have number B here, non-probability sampling methods. And we describe this by saying that these are sampling methods where discretion is used to select. We use our discretion to select what is believed to be a random sample, to be not a random sample, which is believed to be a representative sample. So when talk about discretion here, we mean you use your own judgment. You use your own judgment to decide who should be in your sample in such a way that you have a representative sample, or what you believe is a representative sample. Okay, then we can continue by saying that this method is also known as judgment or purposive sampling, or purposive sampling. So either judgment or purposive sampling. Okay, so now I want us to look at the specific sampling methods, and we'll be starting with the probability sampling methods. We discuss each, and possibly we'll be looking at the merits and demerits of each, and then maybe how to actually select a sample using such a method. So we're also going to have an example to illustrate how you would choose elements from a population using that method. So let's start by looking at simple random sampling. And we say that a simple random sample, from a finite population is a sample selected in such a way that every element in the population has equal probability of being chosen. So these are samples selected in such a way that every element in the population has equal chance of being selected. Okay? Or sometimes we can say it is a sample, or we can say that it is a sample, or we can say that a sample, let me say that a sample is said to be random. A sample is said to be random if every other possible sample in the target population has equal chance of being selected, So that's another way of saying what we said up there. Okay, you can think of a situation. Let's think of an oversimplified situation where we have a population containing 3 elements. So this is our population of size n is equal to 3. And suppose we want to choose a random sample. Of size small letter n is equal to 2. So let's see how many different samples of size 2 can we choose from this population. We can choose A and B as one of our samples, or as a sample. We can choose A and C, and we can also have B and C. So we can say there are 3 different possible samples. There are 3 different possible samples that we can choose from there. Okay, so when we talk of a random sample, we are saying that a sample is said to be random if, for instance, in this situation, if each of these 3 samples has the same chance of being chosen. So if we choose one of these 3 in such a way that each one of them has equal chance of being selected, we say that we have chosen a random sample. Alternatively, you can also choose from here. You can say that you want to choose one element from here randomly. You want to choose an element from here randomly. You can choose, remember, you can choose with replacement or without replacement. So if you're choosing an element from here randomly, it means that you need to assign equal chance, and the chance will be a third in each case. You assign equal chance to every element, then you choose after doing that kind of assignment. Okay, so we need to note that this method of sampling is suitable for this method of sampling. This method of sampling is suitable for homogeneous, is suitable for homogeneous populations. Okay, so the opposite of the word homogeneous is, the opposite of this word, opposite is heterogeneous. Heterogeneous. Okay, so we say that a population is homogeneous if it is similar, it has similar characteristics in terms of maybe the characteristic of importance. If there's similarity, or if everyone has the same characteristics, if everyone in that population has the same characteristics, or if the population is identical, the word identical here is used in quotes. If the population is identical, then you can say that that population is homogeneous. For instance, if you are conducting a survey in a girls' school, if you are conducting a survey in a girls' school, then we can argue that, so I was saying that if you are conducting a survey in a girls' school, then your target population, let's say all the students in that particular school, will be homogeneous in terms of gender. So gender will be homogeneous because every element in your target population will be a female student. But if you go to a mixed school where there are boys and girls, then in terms of gender, you can argue that that population is heterogeneous, and so on and so forth. Okay, so we're saying this particular method of sampling is only suitable if the population elements are identical in terms of some characteristic of interest. In terms of some characteristic of interest. Okay. Then we can add that random samples may be selected using various techniques. May be selected using various techniques. So there are various mechanisms that you can use to select elements in a random fashion. First one is what we call the lottery method. Okay, so these are very simple way of selecting elements in a fashion, in a similar fashion, and it involves you creating some small pieces of paper like this, and then you write the ID. You write the ID is the identity or for every element on these pieces of paper. So usually the ID is in form of a number. So you list, you write the numbers 1, 2, 3, all the way to the population size, which is maybe n. Okay, so the papers should be in such a way that they are identical. You should not be able to say that you should not be able to remember that you wrote a certain number on a certain piece of paper. So this paper should be as identical as possible. And then after you write the numbers like this, you fold them in the same way, in such a way that the number you've written there is not visible. Then you mix them thoroughly. You mix them either in a basket or in a bowl. You mix them thoroughly. And after that, you can close your eyes or you can blindfold yourself. Then you dip your hand and pick one slip of paper. So the number written on that slip of paper shows the element in the population that has been selected or that has been sampled. So you find that when you use that particular method, your personal biases, because you know that humans have personal biases. Personal biases are eliminated in the process of selecting elements of your population. Okay, but you will find that that method is very hectic or is not is very inconvenient when the number of elements in the population is large. If you have just a few, it's okay. If you have just a few, it's okay. So, but if the number is quite high, you use an alternative method. You use an alternative method. So the alternative method which we can use is using computer generated random numbers. So with advancement in technology nowadays, you can use your computer to select elements of a population in a random way, in such a way that your personal biases will be eliminated in the process of choosing the sample. I'll be illustrating that using my computer, using a very simple example. So we can use the computer to generate random numbers. For instance, if I have a target population of containing 10 elements, and I want to sample 3 of them randomly without replacement, that means every element can only be sampled once. So if I run this computer code here, I will get the individuals 9th, 10th, and the 6th individuals in the target population. So these are the guys I'm supposed to study in my research, okay? If I say maybe I need to pick 5 guys from the target population and run that, these are the guys I need to study. If I have like 100 elements in my target population and I want to pick 5, then I will do this. I run the 2 codes and I'll get, these are the individuals whom I'm supposed to study. And as I mentioned earlier, when you are given the target population, it is advisable you start by coming up with a list which identifies every element of your target population by a number. So those are the numbers I'm having here, number 1 to 100 in this case. Okay, so that list is what we call a sampling frame. So I'm using the numbers. So here I'm selecting the numbers, and where then every number here represents some unique individual or some unique individual in the population. So for instance, here I'll sample individual number 90, individual number 82, 49, 67, and the third one. Okay. If I have, let's say 1,000, a population of 1,000, you'll agree with me that it is very inconvenient for you to use the lottery method on a population containing 1,000 elements. Okay, because it is not possible for you to mix those slips of paper in an appropriate way. And then when you start selecting, it is very likely that you'll pick the one that is on top. So if I'm selecting a sample of size, let's say, let me make it 20 now from 1,000, then I just need less than 1 second to get the individuals who I'm supposed to collect data from. So these are the elements that I'm supposed to collect data from if I'm sampling from a population of 1,000, okay? We also have the option of sampling with replacement. So if I want to sample with replacement, so that means I can have the same individual selected twice or enter twice in my sample. Then I just need to come here and change here and write true. I write true there. Let me make it smaller, like size 10. Then let me increase the chance of repetition here by picking like 4. Suppose I'm picking 4 elements or 4 individuals from a group or from a population of size 10, and I want to sample with the replacement. So this is the first sample that I would get. As you can see, there's no replacement. But if I repeat severally, chances are very high that I'll see some numbers being repeated. So like in this case, I have 8, 10, 3, and 8. Okay, so 8 has been sampled twice. Okay, maybe if I repeat again and again and again, maybe I'll see a number repeated 3 times. Okay, but that is very unlikely. Like in this case, 3 is coming twice, and so on and so forth, and so on and so forth. Okay, so basically, that's how you can use a computer to select a sample in a random fashion. So the samples that I'm getting here are random samples, okay? Because number one, this function, the one that I'm using here, this function is designed for randomness. It assigns equal probability to every number in my list, okay? So, and then you find that personal biases, when there is equal chance on every element, it means that personal biases are eliminated. There's no favor on some elements or against some other elements. So basically that's what we call a simple random sample. So next I want us to move to stratified random sampling. So let's look at stratified random sampling, and we say that this method of sampling is suitable for heterogeneous. It is suitable for heterogeneous populations. Okay, so this is the opposite of homogeneous populations. So if you are not able to use simple random sampling because you felt that your population was not homogeneous, then maybe stratified random sampling is one of the techniques that you may want to check out. So here we start by dividing the entire population. We start by dividing the entire population into homogeneous subgroups. Into homogeneous subgroups called strata. Okay, so we start by dividing. The entire population into homogeneous subgroups called strata, and the singular of, so that is plural, so singular is stratum. Singular is stratum. Okay, then you say in each stratum we use simple random sampling. We use simple random sampling to select or to choose to select some desired, I'm using this word desired, what's some desired number of elements. So this number here I'm calling desired here is usually arrived at using some mathematical formula, but we are not interested in that mathematical formula in this class. But there's a way of coming up with a suitable number of elements to be selected in every stratum. Okay, so in each stratum we use simple random sampling. That's the method we discussed up there, to select some desired number of elements. Okay, let me say the required sample size, the required sample, let's say sample of study, the required sample of study is obtained by combining the elements chosen from each stratum. So you combine the elements that you choose from every stratum to come up with your sample of study. Okay. So let's have some illustration. Suppose you want to study the factors affecting the financial performance of companies listed in Nairobi Securities Exchange. We put Kenya here, like that. We want to study the factors that are affecting the financial performance of companies listed in NSE. Okay, so in this case, the target population in this case is all the companies listed in NSE. That's your target population. Okay, so do we know how many companies are those? Okay, so maybe we'll go to that a little bit later. Okay, so but this is our target population, and supposing that this population is heterogeneous, if this population is believed to be heterogeneous, we can decide to create homogeneous subgroups. We can decide to create homogeneous subgroups as follows. So we shall use some criterion to come up with subgroups of this target population in such a way that the elements in a given subgroup are identical or are homogeneous. So we can start by representing the entire population in form of a rectangle, just like the universal set. So we want to subdivide the entire population into subgroups like that. I don't know how many subgroups will be there. It depends with the criteria that we are using to subdivide. But I want us to come up with a criteria of subdividing the companies listed in NSE in such a way that we have homogeneous subgroups. Okay, let me take you to the website of NSE so that maybe from there we can make a decision on how we should group the companies in such a way that we have homogeneous subgroups. So this is the website of Nairobi Securities Exchange, and I've selected listed companies. They are here. As you can see, there is agricultural companies. The ones that are listed here are these are seven. These are 7 companies. Automobiles and accessories, just 1. Banking, we have 1, 2, 3, 4. These are 11. Okay, then commercial and allied services, these are 10. Construction and allied, these are 5. Energy and petroleum, and so on and so forth. So you can see these are the companies listed in NSE. We're able to know how many they are because it is easy to count. We're able to count the number of companies which are listed here. Investment services, manufacturing, telecommunication, and so on and so forth. So with this information now, are we able to come up with a criteria of subdividing the companies which are listed here in such a way that we have homogeneous subgroups? That's the question I'm asking. So as you have seen, a simple way to subdivide these companies is through the sectors they represent. So we have agricultural companies. So we have a list of all the agricultural companies in that subgroup. Then we have the banking companies. We put them in a separate subgroup. We have the investment companies, and so on and so forth. So we'll subdivide the entire population into subgroups where every subgroup here will be a sector represented by the companies listed in the NSE. So that's one quick way of subdividing this group. Then after you do that, let's say this is manufacturing, this is automobile, etc. So in every subgroup, after you do the subdivision, in every subgroup, you are supposed to use simple random sampling to pick some elements out of this. If, for instance, in agricultural, we have 6 companies, you need to use simple random sampling to choose a certain number. Out of the 6, you choose a certain number, maybe 2 or 3. Okay. Then you come to banking, you use simple random sampling. You come to the investment, simple random sampling. So everywhere you use simple random sampling to choose some elements in that subgroup. Then your sample of interest, or the sample that you're going to study, will be a combination of elements from different sectors. Will be a combination of elements from different sectors. So every sector, or every subgroup will give some contribution to the sample of study, like that. So at the end of the day, you will end up with a representative sample, in the sense that every sector of, let's say in this case, every sector of the economy in this case will be represented. So the sample you'll end up studying will be a very representative sample. I hope that method is clear. So next, we are looking at cluster random sampling. And just like the stratified random sampling, this method is suitable for heterogeneous populations. Suitable for heterogeneous populations. Okay, so here we start by subdividing the entire population, the entire target population, into heterogeneous subgroups. Subgroups called clusters. Into heterogeneous subgroups called clusters. So unlike in the previous method where we were subdividing into homogeneous subgroups, here we create a subgroup which contains all the characteristics of the population. So every cluster has the same features as the entire population. Those are what you're calling clusters. You should be able to differentiate between a cluster and a stratum. Okay, and we say that then we use simple random sampling. We use simple random sampling to choose some cluster or clusters, some clusters from where the survey is conducted. So it's good to notice that we are using simple random sampling to choose either one cluster or several clusters from where we are going to conduct our survey. Okay, then from the selected clusters, we conduct a complete enumeration. Another name for complete enumeration, we said this last week, is what we call census. So that means we collect data from every element in the selected clusters. So we do a census in the selected clusters. So the size of your sample is equivalent to the number of elements in the selected cluster or clusters. So let's have an example to illustrate the same. Suppose you want to study the age. Suppose you want to study the age of students in a certain university. So you can say, for instance, in KCIU. Okay. So in this case, the target population is all the students Actually, sometimes say the ages of all the students in the university. Okay, so when you're talking about age, suppose you believe that suppose you believe that suppose you believe that suppose you believe that age is indicated or is driven by factors such as the mode of study. If you believe that students in some modes of study are relatively older than students in the other mode of study, and also the year of study. So here we have things like full-time, part-time, and weekend and DL. Then year of study, we have first years, we have first years, second years, third years, fourth years. And then we also have the course level. So course level, I'm referring to certificate courses. We have diploma courses, undergraduate courses, master's courses, and PhD level courses. So suppose we believe that age changes as the course changes. So maybe you believe that people who are doing masters are relatively older than those who are doing undergraduate course or diploma course, something like that. Or here you believe that fourth years are relatively older than those in the lower years of study. And the same argument. You can have several factors here that you strongly believe are the ones that can be used to indicate the age of students in this particular university. Okay, so now we want to subdivide the entire population body, student body, into subgroups in such a way that the subgroups have almost all the characteristics of the entire population. So let's think about that. And then we come up with a criteria of subdividing the entire population. So I was saying that we need to come up with subgroups in such a way that in this subgroup, for instance, we have all the modes of study, we have all the years of study, we have all the levels of study. The same case with this group. We have all the modes, all the years of study, all the levels of study. Every subgroup has all the characteristics of the population. And one criteria that we can use is we can use the course. We can use the school. We can use the criteria of the school to create subgroups. For instance, or the college, let's call them the colleges. So for instance, if you go to the College of Business, you will find that there are full-time students, there are part-time students, there are weekend students. There are first years all the way to fourth years. There are certificate students all the way to PhD students. Okay. If you go to the College of IT, you will find that there are full-time students, there are part-time students, there are weekend students. You will find that there are first years all the way to fourth years. Okay, there are certificate courses all the way to PhD courses. You go to the College of Education, the same. So we can use the college here or the school or the faculty as our criterion of subdividing the entire population. Another criteria that possibly we can use is the campus. For instance, we can have main campus, because we know if we go to main campus, you will find all the modes of study there. You will find all years of study there. You will find all levels of study there, from certificate level to PhD level. If you go to town campus, the same. If you go to Western campus, the same. If you go to Kitengela campus, the same. So you can also use the campus as your criterion of subdividing the entire population into heterogeneous subgroups. But I think the college might work out very nicely. So we said that once you subdivide your entire population into subgroups, you use simple random sampling to choose either one cluster or several of them from where to conduct your survey. So if we label the clusters as 1, let me use thread 1, 2, 3, and 4. So you need to use simple random sampling to choose one of those clusters from where you are going to conduct your survey. So say, for instance, in this case, you just want to select one of the clusters and then you study that particular cluster. So for instance, if you pick this cluster number 3 here, you are supposed to conduct a census within that cluster. So that means that you collect data from every individual in that particular cluster. So if, for instance, you've chosen 2 clusters, let's say 3 and 2, you are supposed to collect data from every individual that is in those 2. So basically, that's how you conduct cluster sampling. Any question there? So next, let's look at systematic random sampling. And we start by saying that this method of sampling is preferred. This method of sampling is preferred when we have a complete list. When we have a complete list of the elements of the population, of the target population. When you have a complete list of the elements of your target population, that means when you have a finite population. When you have a finite population is when we prefer to use this method. Okay. E.g., we can talk about a list of registered voters in a certain county. In a certain county. It can be county, can be country, etc. Okay. You can talk about the nominal roll. Nominal roll. I guess some of you have already signed the nominal roll, or maybe you're about to sign the nominal roll. So a list of students who are registered in a university in a particular semester. So that's what you call the nominal roll. Okay. Then we can, before we proceed, we can say that a list that identifies every element of the population by a number is called a sampling frame. It's called a sampling frame. So we're talking about a list which will identify the individuals using a number. So now instead of identifying you using your name, we identify you using a unique number. So that list is called a sampling frame. Then we say that in systematic random sampling, we start by deciding on an appropriate sample size. Decide the size of the sample that you want to study. Okay, that is denoted by a small letter m. Then, using the population size, which is denoted by capital N, and the sample size is letter n, we calculate what we call the sampling interval. Calculate the sampling interval denoted by k. So where k is usually obtained by taking n over n, that is population size divided by the sample size. That's what we call the sampling interval. In short, it tells you after what interval you should be picking a new individual into a sample, or you should be selecting someone into a sample. Okay. e.g., we can illustrate that, e.g., if we have a population of size n is 100 and we intend to select and we need a sample of size n is equal to, let's say, 20, then the sampling interval is given by k is equal to n over n, which is 100 over 20 is equal to 5. So the sampling interval is 5. That means we should be picking an individual after every 5 individuals. Remember, we started by saying that you have a list. Let me put the list on a straight line like this. You have a list of all the elements in the population. So let's say we have 1, 2, 3, 4, 5, let's say 6, all the way to, so let me say this is 10, this is 10, 15, 20, 25. So these are my sampling intervals. Then 30, 35, 40, 45, all the way to 95, 100. I have, and my population is of size 100. So here the line is broken here. So like that, and we continue at that point. So so these are, you compute the sampling interval, and these are what we are calling the sampling interval. So this one interval of 5 units, this is another interval of 5 units, another interval with 5 elements, like that. So this is your list. This is your list now, your list or your sampling frame. So this is your list, like that. So you have a list which identifies every individual with a number. So this is the first individual, the second one, all the way to the 100th person. Okay. So once you do that, this is how you select the first element. So the first element to be sampled, is chosen using simple random sampling method. Is chosen using simple random sampling method. That's the first method we discussed up there. Using simple random sampling method from among the first k elements in the list. So when you go to your list, this is our list. So we are saying that the first element is chosen from the first k element. So in our case, k is 5. So we're talking about the first 5 elements. So from these first 5 elements, you use simple random sampling. So you can use your computer to pick one element from there randomly. You pick one guy from there randomly. So we're saying from the first 5, in this case, 1, 2, 3, 1, 5, we use simple random sampling. So I'll go back to my computer and I'll try to generate one number. Out of these 5 numbers, I pick one at random. Then we can try to pick a sample. Out of the 100 elements, I want us to pick a sample of size 20, but I want to use simple random sampling to pick the first element here. So let's go to the computer briefly. So back to our R studio here. I'm setting up my population size, or I'm selecting from a group of 5 elements. I'm selecting from a group of 5 elements, which I'm calling X here. Then from those 5, I want to choose just one element randomly. I choose one of the individuals randomly, and there's no replacement. So when I run this code, the first element to be chosen is 5. Okay. So I prefer that we choose another value. Let's choose another starting point. So if I choose another starting point, I'll get a 3. So I think I'll start with 3, not 5. So back to our whiteboard here. So we're saying that the first element to be chosen is this guy here. So maybe if we are, this is our sample. So the first guy to be chosen is 3. It's the first element to enter the sample. So using simple random sampling. The second element to be sampled, is obtained by taking the first element. You take the value of the first element plus k. So this is our second element. Will be given by the first element plus k. So for instance, in our case, the first element was 3 and our k is 5. So the second element is the 8th item in the list. So you put here 8. So the 8th guy in the list goes into a sample. And then the other elements are put in a similar way. So the third element will be given by the second plus k. In this case, this will be 8 plus 3, which is 11. So the 11th individual in your list is the one who goes to the sample, and so on and so forth. So the fourth guy will be the 16th guy, the 16th element in the list. So and so on and so forth. So we continue like this. We continue like that until we attain our required sample size of 20. So this is what we did. We picked this element, then we have a jump of 5 elements to the 8th element. Then we jump again to the 11th element. We jump again to the 16th, like that. So we'll be jumping with intervals of 5 elements all the way until we pick the last element here. And who will be the last element, who will be the last element to be picked from this list here if we follow that procedure? As you'll notice, this first part here is picked randomly, but the remaining part here is not random. This is a systematic, and that's where actually the name comes from. This part is the elements here are picked systematically. We know the element that will be picked in advance, even before we select. As long as we have known the first element, the other elements are coming or join the sample automatically. The other elements join the sample automatically. Okay. Thanks for that. I'm getting corrected that the third element here, we are adding 5, not 3. Yeah? So this will be 13. So this guy here is 13. That's 13. Huh? So even here, so this was 13. Then we add 5. The next guy will be 18, and so on and so forth. And I had asked a question: who will be the last element to, or what will be the last element to enter the sample? Let me hear what you say.